to give a talk. So Elif has a degree a bachelor's degree and a master's degree in computer engineering, and actually a PhD in bioengineering, and she's currently working as an associate professor at the Middle East Technical University. She has worked on a couple of EU-funded projects, and she has a wide variety of interests, actually, ranging from serious games, mixed reality, AI, reinforcement learning. And I assume she will take us on a wild ride through these areas today. And with that, I'm happy to hand over to Elif to give it away.
Thank you so much, Günther. It has been a pleasure. Thank you very much for the nice introduction and for the kind invitation. Actually, as you said, I mean, while giving the title of the talk and also while preparing it, I try to touch too many buttons and many topics. So most probably I'll be going quite lightly over those, but I'll be very happy if you can ask in-depth questions at the end. So my purpose is mainly to give like an overview of what we are doing at Metro and in some of the EU projects and what is next. So first of all, I will start very briefly with the terminology, and I will give some examples. One of them is like a quite new study on a virtual museum where we have the VR and mixed reality outcome, and then we will have a look at it. What if we did it in basic design, sketch recognition, where there is a touch of machine learning, and a final example from a very simple reinforcement learning background, but with games as well. It is just to open a discussion on other topics as well. So we have other research continuing on that aspect as well. So, I mean, we are always interchangeably using these aspects like virtual reality, mixed reality, augmented reality, but whenever we are talking about virtual reality, as the name suggests, it is like a completely virtual environment, but as augmented reality is basically like more of a layer, so the reality is still there. You can think it like the Instagram filters or the Snapchat filters and so on. And mixed reality, actually, you are very much aware of your surroundings, but also there is a 3D mapping of your environment, and you do interact with 3D holograms. And even two or more people can update all those holograms in real time as well. So serious game is a little bit a difficult definition. So we are all familiar with some video games. They are mainly for entertainment. But unfortunately, the serious game, since there is this adjective on serious, like serious, we do still need entertainment. It doesn't mean that these games should be serious or not, but they should have ulterior purposes. This could be like education, defense, or changing some of the habits of the people, or for rehabilitation. And that's why, since the serious institutions do prefer them, we are calling them like serious games. But recently we started to define them as like transformational games, because we would like to change things in people, their behaviors, their rehabilitation exercises and everything. So these are some of the rehabilitative serious games that we were performing on Down syndrome and also neglect patients. This is just to give open a parenthesis on, we can use games for different purposes. And while doing the games for neglect is a syndrome which happens after a stroke. Let's say that you do have a stroke on your right side. You do not perceive the objects on your left side, even though you don't have any problems with your eyes. So it causes quite difficulty in your quality of life, driving, even eating, because you don't see that there are other things in your plate on the left side. So that's why we tried to develop a real-time color-coded feedback, and this was an FP7 project while we were in Milan. So why the serious games are this important or this used in education? Because it is quite easy to do at mapping. So in education, we do have like students, now we do have players. We do have goals in games, we do have assignments or final exam as the boss monster and so on. So this is quite easy to do such a mapping in reward and the punishment mechanisms as well. But whenever we are talking about the simulation, I mean, even I may ask you what is going to be the predicted weather outcome tomorrow at 2 p.m. in Vienna, and if the answer is like, I don't know, 15 centigrade degrees, this is also a simulation. This is also a result. So we don't need any interaction, we don't need any visualizations, but of course there are advanced visualizations for simulation as well. But the main difference from the games is that we don't have interaction. So I will start with a recent example. It started like with a very philosophical discussion with my student and so on, and it evolved to a virtual museum design in PC, virtual reality and mixed reality environments. So this student of mine, she was very much reading Foucault at those times, and she was reading Heterotopia, all these formlessness, placelessness, and so on. She said that, I mean, can we design a virtual museum like a heterotopia? Heterotopia means, I mean, there are different definitions, like areas of resistance that intensify knowledge, but it also means like worlds within different worlds. So can we think heterotopias as different media where we can integrate different realities, different places, and different forms in a virtual and mixed reality? So this was where the discussion had started. And the embodiment is actually making those, let's say, transparent or way more abstract concepts to become way more materialistic. So we said that could we use all these concepts in the philosophy? Some of them are, as I said, borrowed from Foucault. Is it possible to create an environment where you can create what you would like to create? So that's why we talked about like world making. So, and as a prototype, we said that why don't we create virtual museums? Because it was just after the pandemic, and we both of us missed a lot visiting museums, and we were trying to navigate them in an online way. So we said, why don't we use museums, since it is a combination of different art forms and also interaction forms. That's why don't we use virtual museum as a concept for heterotopia, for placelessness, and for world making. So that's why we had developed like PC, VR, and mixed reality of this interactive environment, but we also used some algorithms in order to make because in the end you are designing like a physical space in the virtual environment. So we said that can we make it way more automated? So we use some automation algorithms there as well. And we tested it with like 30 participants first, and we tried to understand if it's usable, if it's technologically accepted, and if the people do feel like they are present. So as I said, since the initialization of this concept was mainly on the philosophy, so we talked like, could we create like grids of specification? Could we create the operating table as very much mentioned on the architecture? So we said that why don't we use architecture as the use case? So that's why we had began to design automatically this virtual museum as a concept of heterotopia, world within worlds, and reordering of places. And at the end, I'm going to show you, at the end of this section, I'm going to show you a video as a showcase to better demonstrate what we are talking about. So that's why we also try to embed this collocation, embodiment, as I said, making the abstract things concrete. We use the virtual reality and technology. So it was not only like a user-generated content, but it's also designing for designers. So as I said, since this is also like a physical reflection of virtual museums, and in the end, we are trying to define the space well enough, we use generative adversarial networks, cellular automata, and subdivision algorithms just to see which one is going to be way more efficient, because in the end, we are trying to create these world within world in a very responsive way, in virtual reality, in mixed reality, so it should be quite efficient as well. So that's why we created this operating table for the liquid architectures, and these are some of the example interfaces. So at the beginning, you are giving some very initializations and so on, but rest of it is mainly automated. And the idea is you have like both quite miniature outcomes, but also you can make them as real world updates as well. So for the sake of easiness, it is always easy to start with small designs, but then making them enlarged and so on. And we also used hand menu for virtual reality environments. Here, the main thing was we said, why don't we mix several different medium to this setup? So there were like images as paintings, 3D models as sculptures, audio, video, text, and so on. But of course, there were things to be considered. I mean, how are you going to type something if you're using like two controllers and so on? So there should be some easy UI interfaces to make it as well. So we worked on that either. So how should we import some digital asserts? How are we going to use the for that and so on? So we use lots of artifact classes, button generation, and we worked a lot on the easiness of the UI because it should be adaptable not only to PC, but virtual reality and mixed reality environments, and they should be quite usable. These are some of the use cases from like the art canvas view, artifacts, and we try to say what is available in a museum and how can we make it like aesthetically becoming, how can we create this specific grids where there are some context, but as a whole as well, world within world, it should make sense. In the end, you do have an exhibition of painting somewhere, sculpture somewhere, audio somewhere, but as a wholesome experience, it should still make sense. So that's why it is a heterotopia world within world experience. And we use lots of construction elements, and you can change the texture. You're going to see that basically you are just starting from scratch. You are designing a building, but also user experiences. And these are how you can change the light settings, grid systems, and so on. And it is also how you can customize the generated content as well. So you can export some of the assets and play with them either. So as I said, and there are some growth algorithms where you are optimizing the space available, where to put the stairs, how to optimize the doors, or windows, and so on. So these are some of the examples of room generation algorithms. And this is the automated generation of the built environment. And we try to test how the users do feel about this. First, we try to understand their experiences with VR, and if they are already very immersive people, and then we try to understand how they do prefer the lighting, interaction, procedural generation preferences. And whenever we acquired these semi-structured interviews, these were like the main highlights after they used the system. So with the PC, VR, and MR, as you may see, with the PC, the fun is way more like highlighted, but interaction is more highlighted with VR, and with the mixed reality, it is the focus is mainly on design, and the frequency of these words is actually telling a lot. And I'm going to briefly mention how they do prefer it. And there were different medium preferences according to the media type. Some of them have preferred like a video in virtual reality, and some of them have preferred art canvas and so on. And depending on the environments, some of the medium types were preferred a lot. I mean, as you may see, the 3D model is way more balanced, but with the audio, I think since it is way more immersive, audio was mainly preferred with VR, for example. And there were different lighting preferences according to the tasks, because in the end, you are sometimes doing visitation, sometimes creating, modeling, taking the outcome, and there were different Either they want some warm colors or cold colors and so on, depending on the tasks that they were performing. And we also try to evaluate which procedural content generation algorithm worked better when they were trying to create the rooms and the space as well. And for the system usability, still PC was quite high. Mixed reality was like in between, and lowest was the virtual reality, actually, as a surprise. And these were some way more in-depth system usability and tool competence differences. And in the end, all these three topics were technologically accepted. Of course, as I said, the PC was way more easy to use since people are way more used to it. But still, for such a complex system, the outcomes were quite nice, actually. And we also try to understand the presence evaluations of them, what is their possibility to act, the quality of interface, self-evaluation, performance, and so on. Again, they were quite broad when we are talking about the PC and VR. Mixed reality was having lower scores on those aspects either. So as a result, what we understood was this operating table approach, where you can create the both the environment and environment within the environment, that world within world can be used quite well with the virtual reality, and transferring a concept from philosophy has helped a lot. And VR was mainly because of its, like, you are way more alienated from the real environment, and mixed reality was quite powerful in that aspect. And the usability was way more, let's say, in balance for the environments. And there were different preferences regarding the growth algorithm. So overall, the total score suggests a multi-layered approach to creating heterogeneous is quite useful, and people were accepting those environments, and they liked it, actually. So I will show you the video. I don't know if it's going to work. There was audio as well. And so this is just the use case of how you can use this technology. So this is a showcase of how the construction algorithms, partition algorithms do work. You're mainly selecting only the focal points, and it just opens the lays out the structure, and you can edit them later on as well. And with the VR version, we try to minimize the text, and we try to upload the link, and we used shortcuts, and it was mainly using the controller effectively. Of course, the VR felt more immersive while designing the outcome as well. And the hand UI has helped a lot. And we mainly worked on the menus. And if there was something to type, we tried to make it as easy as possible. So but it was one of the main problems, the typing. That's why we use mainly several assets where they are easily fetched from online. It was real time, so we needed to have lots of performance considerations either. And this is what I was trying to mean while talking about like the low value, small assets, and then making them real scale, playing the scales and so on. So you can play with your hands as well, make it for more gigantic or with the real life dimensions. Well, yeah, it was quite a long video, but I think it summarized the first section well enough. So this was like an extension of what we were trying to work in the previous years as well. We started mainly with a collaboration with the architecture department. So the main concern was that in our university there is this basic design course, and this is quite important. But we are just giving the students all these papers and all these 3D models before they even start thinking in 3D. That's why we said, why don't we create a basic design in mixed reality. All the backgrounds right now is all you see is black, but since it's a mixed reality application, and there are all these easy to use assets and grouping, ungrouping, and so on, and you can create quite complex outcomes using all the tool features which are very much common in known environments. And then afterwards, we made an analysis to understand how the designers were actually designing these objects. Where were they starting, how they were in the linkages, and if there were any problem with the design when they were going back and so on. And that's why this is a tool called linkography, and we have like acquired lots of data with mixed reality and try to decipher where the designers changed their minds, how they had done some critical moves, and how they understood that they continue with the design. And they actually felt way more comfortable with mixed reality rather than the real environments. So these are some of our students who are testing the system, and it is possible to create very long and complex 3D models as well, and it had quite nice usability. We also had a virtual reality aspect of it in previous years. Again, we are mainly giving the cards and all these paper to the students, but first we need to teach them how to think in 3D. And it was a very nice example of if we can use VR as part of a basic design course, and if it would really help. And this is another study from 2021. It is actually, we thought about if we can use sketching as a game mechanic. Because, I mean, we are all very much familiar with sketching, and it is some of the things that we are using for in the history as well. There are lots of nice games on that. So we said, I mean, could we use it could it be possible that whenever you are navigating in the game, you will be drawing a few things, and the system is going to recognize it, and based on that, the scenario will evolve. I mean, if there is a door, and if you are drawing a key, the door will open and you will continue. But if you draw something else, the scenario is going to unfold in a different way. And as I mean, we are using the sketching a lot in very simple games as well, but they are very much part of us, and it is a part of our communication. And we use this data set of quick draw, where there were like 345 classes with over 50 million sketches. And we trained some neural networks to make it like real time, and we try to understand the accuracy and prediction outcome and they were making the game to unfold in different ways. And so we used this SNE algorithm to make the sketches. And as you may see here, for example, circle and compass are quite similar in the data set, and the things may unfold quite very differently. And we use CNNs and LSTMs, and we use like 70% of the data set for training, 15 for validation, 15 for testing. And then we embedded this we use the Barracuda package to deploy the trained model. So you are navigating in the game, and then you do something, and there is this thing that says the door is locked, sketch to open, and you're drawing a key, and then the things are unfolding and so on. Or next time cubes will not work, so we are trying to give some clues so that they are triangles and so on. So it was a very basic mechanic, but and it was a very easy game to play, but people enjoyed it a lot. Once again, we were convinced that the sketching is just at the root of us. So what if you do draw it, circle or compass and so on, or try something lighter than air, and then the protagonist draws a balloon, and then she flies out of the occasion and so on. So it was a very simple, and this was a conference proceeding, and there were like 18 participants, and we tested their, again, usability as well, and they enjoyed the game a lot. And there were also the gameful results, and the playfulness was quite good when compared to the other options. As in another example, this was not a game, but this was a 3D visualization where actually all the things have started. I mean, on the left, on the upper left side, this is my door. This is the corridor that I'm in, and this is a 3D model of a house. And what you can do is that there is this Revit the software where you can edit, update, and use the 3D models. And for example, you can add some doors to the surrounding, some windows and so on. And in the real time, you do see the if it receives well enough heat, or if the lighting is okay and so on. And this one was on the mixed reality, and we performed it for the virtual reality as well. We used quite nice visualizations, also real-time calculations of the heat at the house, and it is important for an architect to think about in terms of the sustainability as well. Now I will switch to something completely different. So this is also another extension of serious games. So in 2017, we started a European Union project called eNotice. It was European Network of CBRN Training Centers. And actually, it has evolved right now to eNotice 2, which I'm still part of. And then we do also have a new project called Innovation, where we are working on CBRN, like chemical, biological, radiological, and nuclear attacks. But since we are like computer engineers, we are trying to develop some technologies either to train those first responders, or try to make it easier to design or create some of the training programs. So, I mean, eNotice was a networking project. That's why there were lots of joint activities, which means that you need to form some setups and real examples, real training programs. And the thing is that when we looked at, so at the beginning, the idea was like, we were supposed to create a very simple single shot game. But after going to a few joint activities, we said, why don't we, there are so many similarities with these events and everything, why don't we create a game generator to create those simple games? So, but at the beginning, there was quite a resistance, especially when we talked about the games, because people who are like first responders, they would like to do real exercises. So they are really like burning cars, or they are really putting them in very difficult situations. And you are going there and you're saying, okay, we're going to develop a game. And at the beginning, it was understood as if it's like a cure for all, and the game is going to replace everything. But actually, after quite understanding what their expectation was and what we are trying to do, it was a nice opportunity to build a language actually to come up with that. So for example, this is an example from an exercise from France. This is an hospital scenario, and on the screen there you do see that there is an attack to a train station, and there are lots of different role players there, and they are like responding to the phones, arranging the hospitals and so on. So it was a real scenario. And this was another one from Brussels where they are testing the decontamination exercises. So they are really very physical exercises, and they need to make those trainings. So our purpose was not to replace these trainings, but to come up with something where they can remember what was happening there and how they can repeat what was available there. So, and all these scenarios are quite complex. Everybody is communicating with everybody else. There are lots of different rules, so you need to make it better. As I said, we said, why don't we create a game builder instead of creating small games, since they had so many properties, and we use this state machine of Unity. And on the upper side, you do see very basic assets, for example. We were just trying to understand what's going to happen after the attack, what's going to happen, what will be the states and so on. And we were just modeling basic objects, and we were testing if they were acting correctly. And just by replacing the tag of those assets, we were fetching the real objects. And as you may see, the developed games were on the below line. So it was quite powerful to create all those mini games, which were quite enough for the repetition of those physical exercises. And Günther is going to remember, actually, just before the pandemic, we had organized some physical exercises as well. We actually went to a mine because some part of those CBRN fluid attacks were developed in a mine, and they had tested all these virtual reality games and mixed reality games just inside the mine and so on. And we had built the mine completely the same way on the upper side, and we had created a completely different game again for disasters and so on. And since again during the COVID, some of our civil engineering professors told us that we cannot do the laboratories right now, what are we going to do and so on. So we had performed some virtual reality and small games just to both cheer our students up, but also teach them the basics, since it was not possible to attend the classes. Just this final section, I think I have 10 minutes at most, but I will wrap it up quite. And this is a completely different concept, but I'm just trying to make you think how reinforcement learning. So we talked about like human developed games or environments, and then we had machine learning as a game mechanism. Right now, the question is, what if we do use reinforcement learning? If you're not familiar with the reinforcement learning, actually the main idea is that there is an agent. This can be a human being, a robot, an NPC again. It can be anything which interacts with their surroundings on a reward or punishment basis. Actually, it is like the summary of our learning system, right? So we are touching something, a burning fire, and we do see that it wasn't a nice experience, and we learn not to do it again. So the environment is giving us some feedback, and but I mean, in this diagram, you do see that, okay, the agent, it is usually visualized as the brain, does some action, and the environment is giving some feedback. This could be some reward and also like observation. But it is not like a closed loop. Actually, it is like a sequence of actions. That's why it is quite difficult to teach an agent what to do. So, and with the reinforcement learning, we said that, okay, in general, in the AI mechanisms, all these relational networks, there are quite complex outcomes where, so this was like from 2021, so it was before ChatGPT era, before the relational networks were this popular. So the idea becomes like, how are we going to extract relations in an image? How are we going to make sure what is the best strategy whenever we are training an agent for a game? How are they going to understand what is on my right side, what is on my left side, upper side? How are we going to drive all these relations? And there were some data sets to, for example, to answer some relational questions. What is the color of the object that is close to the blue object? So where am I when compared to the other things? So, and there were lots of attention networks to do that, and what the agent is focused on, how to do that, and so on. We said that why don't we use a combination of these architectures? And there was this PredNet experiment where you are like using the logical structures to understand the relations of objects in images. We said that why don't we use these architectures and create a baseline box world environment and create a relational grid world and put it like a gameplay where you are trying to train different agents with different mechanisms. And what we try to do is that it was not only a relation like a one-shot relation, but also way more complex one to understand that, okay, there is this monster and I need to get this sword first to do this and that. So that's why we trained these convolutional networks in the PredNet, and we created a very basic grid-based environment, and we had the agents, some teleportation mechanisms, terminals, walls, and so on. So we create like random game environments and try to understand if our agent extracts the relationships between those objects and what is a mountain, when am I using it, and so on. So it was quite a nice experiment for us. It was a very simple setup, but at that time it was one of the first ones where there was not only a single relation, but way more, let's say, complex one. But of course, there are recently way more advanced models. So at that time, we created a novel relational grid environment. There were like 8 objects with different functions to measure the RL agent's relational representation understanding, its capacities. So that's it for me right now. As I said, I mean, it was the CBRN part was mainly from the eNotice project. Right now, we are continuing with it with the eNotice 2, where we are actually developing scenarios in a lab environment and teaching the first responders to that. Innovation is a very, it has started like in September 2024, and we are trying to make an ontology-based visualization tool, again, for creating better training possibilities for CBRN scenarios. So thank you very much for listening. I hope I didn't extend my time. So I'll be very happy to receive questions. Thank you for your patience.
Thank you. Perfectly in time, and congratulations to eNotice 2.
Thank you.
Okay, we have some time for questions now. So if you have questions, feel free to unmute yourself and just ask or put it in the chat as well.
So no questions is always a little bit tricky. Either I was very fast and I talked too much, or it was very clear.
I have a couple of questions indeed.
Okay, go ahead, please. Thank you.
You know, maybe for the eNotice, where you basically build the different scenarios. I mean, these scenarios are very specific, right? So you have a certain scenario, you have to build that scenario, you have to build it with respect to that scenario. So can you comment a little bit on how, you know, how much effort building one such a scenario takes, basically, and what could be reused, for instance?
Thank you for the question. I mean, so the scenarios are very complex, as you said, but as if you do think them like stories, there are very much similarities as well. I mean, it can be like a chemical scenario or radiation, something bad happens, and then some of the objects to interact with the environment, and then the first responders should arrive. There are some procedures. So those procedures are very much rule-based, right? So you know what should be done. And you are trying to, so you are way more, let's say, free riding at the beginning, but when it comes to the procedures, you are way more like, okay, this is not a good thing to do, so it is not possible to do that, or you're trying to teach what is the correct thing to do. So that's why after the real procedure, after the event happens, actually it is way more like structured. But of course, I mean, this was like the initial version, but of course, we need to have other tools to make it very more dynamic. People are going to make mistakes. I mean, here we were trying to disable the mistakes and we were trying to teach the right thing to do. But people are going to do mistakes. And what is next then? So you need to have lots of nonlinear scenarios to unfold it. That's why the state space gets quite complex as well, and you will have difficulty to reuse some part of it.
All right, thank you. Maybe while people are still thinking, maybe to extend on that. But you said you're trying to teach the right thing to do, right? So if you're doing serious games, there is always this kind of danger that, you know, people are gaming the game, so to speak. They're doing stuff that is good to have a good like score in the game, but that doesn't necessarily mean it's the right thing they're learning, right? If you are like in this very critical safety related scenarios, how do you make sure that people really learn the right thing?
So what we do is that, for example, with the neglect, what we did was, Günther, for example, let's say that so the patient is affected by neglect. That's why they are only playing on the right side of the screen, right? So we programmed that Novint controller. It was a 3D controller. And if you are only taking things on the right side, it was pushing you to the left side to pick things there for the purpose of the rehabilitation. Or whenever you are doing wrong things, again, visually you are seeing that you are doing something wrong. And if you are about to fall down, for the Kinect-based games, for example, the system was shutting itself because it was like a home-based rehabilitation. And of course, it was connected to the medical doctor. But if something bad happens to that patient, it is our responsibility as the engineer. So you need to make sure that you are teaching the right thing to do. But of course, it is sometimes not that easy. With the VR, we are way more like showing with the visuals and the UI and so on. But for rehabilitation especially, we are physically teaching them to do the right thing.
Thank you.
You're welcome.
I have a question regarding the sketching game.
Oh,
Were
thank you.
there any more complex examples than like shapes or balloons?
There were like 8 very simple shapes, the balloon, circle, compass, but we have chosen all those subgroups because they were easy to mix up. So you are trying to draw a circle and the system recognizes that as compass, or you are not doing drawing it well enough. It recognizes as the circle and you get stuck, you need to find a solution and so on. So this was the idea. We were trying to we have selected similar shapes to check if the accuracy of our system is good enough.
Okay, I see.
Do you want to extend that to like more complex stuff?
It would be great. I mean, it was actually a class project, and we liked it a lot. And then we started to work on it during the summer as well. And then we said, why don't we submit it to a conference and so on? So it was just like a periodical thing. But the participants had so much fun, and sometimes you are putting so much effort, all those like 5-year projects and so on, and then in a class assignment, something else can just bloom up.
Any further questions? I mean, I have one more point of discussion probably.
Please.
You raised the heterotopia at the start of the talk.
Yeah,
Yeah.
I wanted to make a philosophical discussion with you.
So basically, I think one could argue that every game is a heterotopia in some sense.
I agree with you. I mean, we can say that with all these but all these other concepts and requirements, and we said that why don't we not only choose the heterotopia, but let's discuss the embodiment and also placelessness and so on. After all those arguments and so on, let's say, why don't we create something where the different forms coexist? That's why we started with the museum, but of course it can be anything. I mean, any playground, as you said, any game. You are creating world within worlds, right? Or literature is something like that. No, I mean, you are creating lots of different worlds and so on. But it was very nice to develop something technological on such a philosophical topic, and it was quite nurturing. It is one of my favorite studies, to be honest.
Yeah, I mean, it's an interesting concept, and I think it's used in architecture quite a lot.
Exactly, yeah.
But if I remember, Foucault also talked about it being not only about the spatial part, but also about the stuff you don't see.
Exactly.
So, like, if you rebuild it,
So all this space, placelessness, yeah. That's part of it.
So if you like, VR is a very visual medium, right? So how can you account for these other aspects of heterotopia?
I mean, with the VR, it is way more difficult. You are right about that. But there as well, we are trying to start with an empty environment, right? We are creating everything there. I mean, all those complex algorithms to do the matching and partitioning and everything. So you are starting with all the space available. And then you are creating an environment, but there is still so much space to navigate and so on. With the mixed reality, you are also seeing the reflection of the real environment. So it is an additional space. There is like something beyond, right?
Yeah, true. With mixed reality, it even blends together then.
Exactly.
All right. Any other questions before we are getting too philosophical? If there are no further questions, thanks very much again.
Thank you very much, Günther.
Taking the time to prepare and present today.
Thank you.
And
it has been a pleasure. Hope these students have enjoyed it as well.
I hope so too. So, have a nice day, everybody, and hopefully we can catch up at some point.
Okay, thank you. Bye.
Thank you. Bye-bye.
Thank you for the talk.
Thank you very much for the
Thank you
presentation.
very much. Thank you. Bye.
Thank you. Bye.
Thank you. Bye.